going to take a look at how to find the distance between 2 points on a coordinate grid. Before we get started, please take a second to think about the warm-up and just describe how you would find the shortest distance from Kaylee to Isabella. So hopefully you remember that the shortest distance between 2 points is a path that is on a straight line. So it would be something like that purple line I just drew there. And in order to find this distance, we could work with how we've created slope triangles, and we could draw a right triangle that takes us to there and then up to Isabella, and then we could use the Pythagorean theorem to find this distance right there. So our goal today is to figure out another way, instead of drawing a right triangle in between the 2 points, to find the distance between those points. So again, right now we would need to count the distance from Kaylee over to here, and then from this location up to Isabella, and use the Pythagorean theorem to find the distance of that orange path. Now, what I have highlighted in green right here is that sort of summarizes the warm-up. It's what we just talked about. So what we're going to do now is we're going to take a deeper look into how could we find the distance between 2 points without having to use Pythagorean theorem. So what I want you to do before you proceed is to find the length of each of these legs, or each of these lines that we have on here, by drawing in the right triangle and using the Pythagorean theorem to find the length of the hypotenuse. Then restart or unpause the video and check your answers. So if we draw in the right triangle here, we get a distance of 2 right here and a distance of 1, 2, 3, 4 right here. So if we use Pythagorean theorem, we would have a squared plus b squared, so we'd have 16 plus 4, which would give us 20. So this would give us a distance of the square root of 20. And if we were to simplify that, we could break that up into the square root of 4 times the square root of 5, which would give us the 2 square roots of 5. So we have the distance between those 2 points as 2 square roots of 5, or the square root of 20. If we were to do the same thing for this distance right here, we would have a length of 1, 2, 3, 4, 5, 6 down here, a length of 2 here, so we'd have 36 plus 4, which would be 40. So that would tell us that this length would be the equivalent of square root of 40. And if we were to simplify that, we can see that that would be equal to the square root of 4 times the square root of 10. So that would be equal to 2 square roots of 10. And then you could change those into units, or like you could do 2 times the square root of 10 to find out what that is if you wanted to know the decimal number. For this third line, we'd have a length of 2, and then we'd have a length that goes over to this point, which would be a length of 8. So we have 64 plus 4, which would be 68. So we have the square root of 68, and if we simplify that, we would have the square root of 4 times the square root of 17, which would give us 2 square roots of 17. And finally, if you are looking at this one, you have a distance of 6, and then you have a distance of 8. So you have 64 plus 36, which gives you 100. So the square root of 100 is 10, so it tells you the distance between those 2 points is a length of 10. So again, this is a strategy that we can use to find the distance between 2 points. We could create a right triangle using the 2 points we have and find the distance of the hypotenuse of that right triangle. That is the distance between those 2 points. So what we want to do is we want to find a quicker way to do that. So go ahead and complete the step 2. I'm not going to go over that, but what you're doing is you are just repeating what we just did by graphing the points and finding the distances between them. And what you want to do is you want to use step 1 and step 2 to sort of answer these questions for step 3 and 4 and what I have highlighted in green. So what we want to think about is, what if the points are so far apart that it's not practical to plot them? If you take a look at this, we have the points 1534 and 4270. They are very, very far apart, and it might be hard to put them on a graph where you only have 10 units to the left and right and up and down. So what can we do to find the distance between those points without having to graph them, count up the spaces in between them, and then use the Pythagorean theorem? So if we look at this, we want to write an expression for the length of the horizontal leg using the x coordinates. So if we wanted to find the length of this leg right here, what we would do is we would take 42 minus 15. And that would tell us the length of those 2 coordinates. So if we wanted to write an expression, we could label these as, let's say, x1 and y1, x2 and y2. We could say to find the horizontal leg, we would have x2 minus x1. So what we're doing is we are subtracting the 2x coordinates. And if we wanted to do something similar for the y value, we would take 70 and we would subtract from that 34. And so what you see there is we have y2 minus y1. And what we're doing there, again, is we're subtracting the y coordinates. So if we wanted to think about this and use our expressions from steps 3 and 4 in the Pythagorean theorem to find the distance between points A and B, 1534 and 4270, what we might see is that the distance from AB, so we have AB squared is equal to, so the horizontal distance squared, which would be x2 minus x1. We said we could represent the horizontal distance with x2 minus x1. And so we'd square that, and then we'd add to that the horizontal distance, y2 minus y1, right there, or our vertical distance, my fault. And then if we plug in what we have, we would have the distance of AB squared is equal to x2 minus x1 squared. So we'd have 42 minus 15 squared plus 70 minus 34 squared. And if we evaluate this, what we get is we have AB squared is equal to 42 minus 15 would give us, squared would give us 729. And then 70 minus 34 squared would give us 1,296. And then to find the length of AB, we would take the square root of both sides. And that would tell us that AB is equal to 45 units long. So what we can do here to sort of generalize this is we can say that the distance between 2 points is equal to, so we could say the distance squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Or we could say that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So what this is known as is this is called the distance formula. And the distance formula allows us to find the points between two two ordered pairs on any grid, regardless of how far apart they are, regardless of whether or not it's easy to draw a right triangle or not. So let's look at a few examples to see how we can apply the distance formula. So we jump in right away to looking at a problem that's a little bit more than just, hey, what is the distance between 2 points? It asks us, is the quadrilateral with vertices AB, or A, B, C, and D a rectangle? So we have the ordered pairs for these vertices, and we would need to remember what a rectangle is. So what is a rectangle? A rectangle is where you have opposite pairs, so opposite sides are congruent, and angles are 90 degrees. And what does that mean? That means that the sides are perpendicular. So we need to check a few things to see if this is a rectangle. First thing we need to do is see if the lengths of our sides are congruent. So if we look at, we need to find the length of AB, BC, CD, and AD. So we know that AB, if we want to find the length of that, or the distance between those 2 points, we know AB is equal to the square root of x2 minus x1. So we have 1 minus 0 squared plus 5 minus 2 squared. So that gives us the square root of 1 plus 9, which is equal to the square root of 10. So we know AB is equal to the square root of 10. Now we need to find the length of BC. We know BC is going to be equal to the square root of, we have 5 minus 1 squared plus we have 3 minus 5 squared. That gives us 4 squared is 16 plus negative 2 squared is 4, so plus 4. It gives us the square root of 20. Then we have to find the length of CD. So CD has to come out congruent to AB. So the CD better come out to be the square root of 10. So we have the square root of, we have 4 minus 5 squared plus 0 minus 3 squared. So that gives us square root of 1 plus 9, which is equal to the square root of 10. So CD is congruent to AB, so that's good. And finally, we need to find the length of AD. So AD is going to be equal to the square root of 4 minus 0. We're going to square that, plus 0 minus 2 squared. That comes out to be square root 16 plus 4, which is the square root of 20. So what we have is we have the opposite sides are congruent to each other. So we have BC is congruent to AD, and AB is congruent to CD. So what we need to check now is we need to check to see if AB is parallel or perpendicular to AD. And how do we check that? We have to find the slopes of these lines. So we're going to check if sides are perpendicular. So the slope of AB is equal to 1, 2, 3, 1. So 3 over 1. The slope of AD should be, if it's going to be perpendicular, negative 1/3. Let's see. Down 1, 2 over 1, 2, 3, 4. So we have down 2 over 4, which simplifies to negative 1/2. So if we check this, the slope of AB is 3, the slope of AD is negative 1/2. That tells us that AB is not perpendicular to AD, so this is not a rectangle. All right. So again, if you're checking that, you need to check the lengths of the sides, and you need to check whether or not the sides are meeting at right angles, which means they are perpendicular. So in this case, they are not. If you look at the second example, it says, what is the area and perimeter of triangle LMN? So let's find the area first. We know the area of a triangle is 1/2 times the base times the height. And we know that when we're talking about the height of a triangle, we're talking about the perpendicular distance. So in this case, this would be, we want to find an altitude. Okay, so from one vertex to the opposite side that is perpendicular. So if we look at this, we have this right here. Our height of this triangle can be measured as that altitude. So that would be 1, 2, 3, 4. So this height, triangle has a height of 4. So h is 4, and then our base is the distance from M to N. So 1, 2, 3, 4, 5. So we have 1/2 times 5 times 4, which gives us a length of, or an area of 10 units squared. Now, to find the perimeter, what we would need to do is we would need to know the length of each side. If we take a look at this, first we can find the length of MN. We already know that that is 5. We can just count that because it is vertical. Whenever you have a side that is vertical or horizontal, you can just count the distance between the 2 points. But once you have sides like LM and LN that are diagonal, then you would need to take a look at using the distance formula to find those distances. So we know that LM, the distance of that is going to be equal to the square root of, see that point is -3, 0, and this point is 1, 4. So LM would have a distance of 1 minus the square minus -3, so that becomes +3 squared, and then plus 4 minus 0 squared. So we have square root of 16 plus 16, which is the square root of 36. My fault, 32. And if we wanted to simplify this, we could simplify that into the square root of 16 times the square root of 2. So we get 4 square roots of 2. Then we would need to find the length of LN. And so if we wanted to find LN, we would have to take, use the distance formula again, and we'd have the square root of, N is 1, -1 at that point. So we'd have 1 minus -3, so that'd be 1 plus 3 squared, and then plus, we'd have -1 plus, or minus 0 squared, and that would give us the square root of 16 plus 1, which is equal to the square root of 17. So we know the length of LN, we know the length of LM, and so if we wanted to find the perimeter of this, we would have to take, we'd take MN, we'd add LM, we'd add LN, and that would give us, we'd have 5 plus the square root of 17 plus 4 square roots of 2. And if we type that into our calculator, we get an answer of a perimeter approximately 14.78 units. And then our final example says find the length of the diagonal of a square with vertices 0, 0, 3, 0, 3, 3. And so you see what is the fourth vertex of the square. The fourth vertex of the square is going to be 0, 3. And then we want to know the distance from this point to this point. We want to know a diagonal of the square. So to find that distance, it would be easy enough to just draw in our right triangle. So we'd have 3 and 3. So we'd have 9. So if we use the Pythagorean theorem, we'd have 9 plus 9 equals c squared. And then we'd have 18 equals c squared. So the diagonal distance is the square root of 18. So that being said, you can go ahead and begin working on the homework for CG9. If you have any questions, email me, message me on Remind, or feel free to ask the next day in class.